This video is for Algebra section 8.1. Our learning goals. So today you're supposed to learn. The learner will apply knowledge of monomials to simplify them using the product of powers, power of a power, and the power of a product properties. Okay, so those are the things you'll be learning. Our vocabulary terms, there are quite a few of those. First one is a monomial. A monomial can be a number, a variable, or a product of a number and one or more variables. They cannot have any addition, subtraction, or division by a variable. Okay, you could have division with a number because you could turn that into multiplication. Like if it was divided by 2, you could say it's multiplied by 1/2. You can't do that with a variable. So some examples would be something like 3. That's a number. That counts. Another example would be x, because that's a variable. Another one would be 3xy, because that's a product of numbers and variables. Non-examples, so things that do not count, would be something like 3x plus 4. That is not a monomial. Another thing that wouldn't count would be something like 4x over y. That doesn't work. 2 minus x. That doesn't work either. Okay, so those are some ideas of what it would look like. Product of a power means basically, product means multiplying. Powers mean things with exponents. So you're multiplying things with exponents. Basically, they have the same base. So you should notice those are your bases. Bases are the same. And then they have different exponents. If they have the same base, you can just leave that base. You don't multiply them. So if it's 2 to the third and 2 to the fourth, you don't multiply and get 4. You leave the 2 and then add the exponents. So an example of that, if I had x to the 4th times x squared, that would equal x to the 4 plus 2 power, which is x to the 6th. Okay, the next one we have is power of a power. So we have something with an exponent taken to another exponent. And then basically it shows you would just multiply the exponents, leave the base alone. So another example, if I had y to the 3rd, and that was to the 4th power. That would mean I'm really doing y to the 3 times 4 power, which is really y to the 12th. Alright. And the last one we have is the power of a product. Power of a product means basically you have things that are multiplied together inside these parentheses, and they're taken to a power. And this is saying you can basically take that power to each individual thing. So if I had something like 4x inside parentheses and I had it squared, that means it's really 4 squared times x squared, which would be 16x squared. Okay, so those are all of our vocabulary terms. Our prerequisite skills, things that you should know in order to do this, is very basic things. You need to know how to add, multiply, and that's about it. Adding and multiplying. That's all you really have to do. And you need to know negatives, basically how to add, multiply negatives. Alright, so we are going to move on to some examples. Number 1 on the first page of our study guide. You have y to the 5th squared. So we have a power. Oh, sorry, I'm on the wrong page. Let's go back. That's number 1 on the second page. Let's do number 1 on the first page. Number 1 on the first page says y times y to the 5th. This is just two numbers, basically variables, but multiplied together. So this is the product of powers. Even though this doesn't have a power on it, you need to put a 1 there. If there is a y there, it has a power of 1. So base stays the same, and I just add my exponents. So y to the 6th. And that's all you do. Moving on to number 3, I have negative 7x squared times x to the 4th. Alright, well negative 7, nothing happens to that. Doesn't have anything to do with it. But I have an x squared and an x to the 4th, so they have the same base, so I keep the base and do 2 plus 4. So I have negative 7x to the 6th. Number 5, I have m times m to the 5th. And you should notice this looks almost exactly like number 1. You do it the exact same way. The only thing they did different was they used m instead of y. They put parentheses instead of a times. Doesn't matter, you do the exact same thing. So it's m to the 1 plus 5 which is m to the 6th. Number 7, we have rs, oops, sorry, wrong problem. On number 7, we have 2a squared times 8a. Okay, once you get to where there are numbers and variables like this, you may want to rearrange it so it's easier for you to determine what to do. So I'm going to put my numbers in the front, and then I'll always put my variables in alphabetical order. In this case, I only have one variable, so I don't have to worry about that. I am going to put the 1 when there isn't a variable there. And if they're just numbers, I can just multiply those. 2 times 8, 16. And then a to the 2 plus 1, because they have the same base, you just add the exponents. 16a to the 3rd. On to number 9. X squared y times 4xy to the 3rd. Again, I want to rewrite this. I'm going to put my numbers first. So I have 4, and then I'll put my variables in alphabetical order. So I have an x squared, I have an x to the 1st, a y to the 1st, and a y to the 3rd. So 4, nothing's going to happen. X becomes 2 plus 1, and y becomes 1 plus 3. So 4x to the 3rd, y to the 4th. Number 11, we have negative 4x to the 3rd times negative 5x to the 7th. Again, I want to rewrite it, so negative 4 times negative 5, x to the 3rd, x to the 7th. So negative 4 times negative 5 gives me 20, and 3 plus 7 for the x. So 20x to the 10th. Alright, I'm going to erase so that I can get the next two problems in. Number 13, we have 5a squared b c to the 3rd, and we have 1/5 a b c to the 4th. Again, since this is all multiplication, I can just drop the parentheses, rearrange it the way I want it to be. So I'm going to have 5 times 1/5, got all my numbers, then a squared, then an a, I'll put the 1 there, and a b, again I'll put the 1, another b with a 1, c to the 3rd, c to the 4th. Okay, so I'm just rearranging everything so that it'll be easier for me to combine some things. So 5 times 1/5 means I do 5 times 1 divided by 5, which gives me 1. If I have 1 and I'm going to write some numbers after it, or sorry, some variables after it, I don't need to write that 1. I can just leave that. So I'm going to just cross those out. They cancel out. A squared and a to the 1st is going to be a to the 2 plus 1, and b to the 1 plus 1, and c to the 3 plus 4. And it may seem like a lot of work to put in those steps to you. When you are first learning this, you need to show all the work so you will really understand where it's coming from and you'll get the concept better. Alright, so that's all I have. Number 15 gives me 10x to the 3rd, yz squared, and negative 2xy to the 5th z. Alright, so I'm going to rewrite this again. 10 times negative 2, x to the 3rd, and x to the 1st, y to the 1st, y to the 5th, z squared, and z to the 1st. So again, just rearranging all the things that were already there. Didn't do any work yet. 10 times negative 2 will give me negative 20. X becomes 3 plus 1. Y becomes 1 plus 5. And z becomes 2 plus 1. And x to the 4th, y to the 6th, z to the 3rd. That's it. We are done with the first page of the study guide. On to the second page. The second page, they will incorporate some more properties. Basically, we only used product of a power on that first page. Second page, they will use the power of a power and the power of a product. So let's try number 1. We have y to the 5th in parentheses with a squared. This is where they have a power taken to a power. In your notes, power of a power means you multiply 5 times 2 becomes y to the 10th. And that was all. Number 3, We have x squared to the 5th power times x to the 3rd. Okay, so we have a power of a power, so let's take care of that first. That becomes x to the 2 times 5. X to the 3rd, if you don't want to write those parentheses, you don't have to. They don't really mean anything at this point. 2 times 5 is x to the 10th. Now I'm using the same property I used on the other page. So I have a product of powers, two different powers multiplied with the same base. So I have x to the 10 plus 3, which is x to the 13th. Number 5. I have negative 3a b to the 4th all to the 3rd power. So we're going to have negative 3 to the 3rd power, a to the 3rd power, and b to the 4 times 3 power. Okay, so we took that power through to everything. Make sure I did put the negative 3 in parentheses because I want to take negative 3 to the 3rd power, not just negative and then 3 to the 3rd. Okay, because everything's getting the power. So negative 3 to the 3rd becomes negative 3 times negative 3, which is 9, times another negative 3, which becomes negative 27. A to the 3rd's done, and b to the 12th. All right, number 7. We have 4a squared, squared again, and then b to the 3rd. So I'm going to take that squared through to the 4 and through to the a squared. It's kind of like the distributive property, very similar. Oop, I did skip a little work step there. Hope you caught that. A to the 2 times 2 gave me 4. 4 squared is 16. And that's it. Number 9. We have x squared, y to the 4th, all to the 5th power. And I'm going to multiply this through x to the 2 times 5 and y to the 4 times 5, which is x to the 10th, y to the 20th. Hopefully we're getting the hang of this. Erase this page and go on to number 11. We have negative 4x, oh, sorry, yeah, negative 4xy to the 3rd power and negative 2x squared to the 3rd power. So again, I'm going to distribute that power basically. So negative 4 to the 3rd power, x to the 3rd power, y to the 3rd power. And then times negative 2 to the 3rd power, and x to the 2 times 3 power. So negative 4 times negative 4 times negative 4, you should know is negative 64. Can't do anything with x to the 3rd and y to the 3rd. Negative 2 to the 3rd power is negative 2 times negative 2, which is 4, times negative 2 is negative 8. And x to the 6th. Okay, at this point I would rewrite it so they're in the right order. So negative 64 times negative 8 would be at the front. X to the 3rd, x to the 6th, and y to the 3rd. Most of us probably don't know what 64 times 8 is, so make sure we do that. Should be 512, and it is negative times a negative, so it's positive 512. X to the 3 plus 6, because you're multiplying powers, or using the product of powers. So 512, x to the 9th, y to the 3rd. Alright, let's erase that one. Oops, sorry, let's not erase it yet. Let's go on to number 13. Number 13, we have 25a squared. Oops. A squared b all to the 3rd power. And then we have 1/5 abc all squared. So I'm going to take those powers through the parentheses again. So 25 to the 3rd, a to the 2 times 3, b to the 3rd, times 1/5 squared, a squared, b squared, and c squared. Again, at this point I would probably rewrite all that. I can do some things at the same time. I can do 25 to the 3rd. That would give me 125, because, no, it wouldn't. That's not right. 25 times 25 is 625. and I have to multiply it by another 25. So I'm going to do that down at the bottom so that I have that number. So 625 times 25. So I get 15,625. A to the 6th, and I'm going to rewrite this. So I'm going to bring my a squared over here. Then I put b cubed. Actually, let me go back a little bit here. Let's put my other number there before I get to my a's. So make sure we do all this in the right order. So this was times 1/5 squared, which I could rewrite. 1 squared is 1, 5 squared is 25, so 1 over 25. Then I can do a to the 6th, a squared, b to the 3rd, b squared, and c squared. Well, if I'm doing 15,625 times 1 over 25, that's just the same thing as dividing by 25. So wouldn't I just be going backwards of doing what I did here? So I should get right back to 625. If not, you can do the long division and figure it out. Then I would do a to the 6 plus 2, b to the 3 plus 2, and c squared. So 625, a to the 8th, b to the 5th, and c squared. And that is my answer. Okay, again, I'm going to erase this page and go on to number 15. Number 15. And you should notice they are getting more complicated as we go. Not really any harder, they're just longer. Alright, so that was the problem. Again, I'm going to take these powers through the parentheses. So 2 to the 3rd, x to the 3 times 3, y to the 2 times 3, z to the 2 times 3. And then I'm going to take this one, so x to the 2 times 4, and z to the 4th. I would rewrite it at this point. 2 to the 3rd is 8, we should know that, 8. X to the 9th, then I want to put my other x. 2 times 4 gives me x to the 8th, y to the 6th from right here, and z to the 6th from right there, and z to the 4th from the end. Okay, then I can say that's 8 to the x to the 9 plus 8, y to the 6th, z to the 6 plus 4. 8x to the 17th, y to the 6th, z to the 10th. And that's it. And our last problem in this section is number 17. Number 17, we get negative 3a to the 3rd n to the 4th times negative 3a to the 3rd n to the 4th on the outside. So nothing happens to this front part, so I'm just going to rewrite it. Then it becomes negative 3 to the 4th power times a to the 3 times 4 power and n to the 4th power. Okay, and we put negative 3 times negative 3 to the 4th becomes negative 3 times negative 3 is 9, times negative 3 is negative 27, times another negative 3 is positive 81, so times 81. A to the 3rd times a to the 12th from right here, rearranging it, n to the 4th, and another n to the 4th. Negative 3 times 81 is negative 243. A to the 3 plus 12 power, n to the 4 plus 4 power. Negative 243, a to the 15th, n to the 8th. And that is the end of section 8.1.